Yeah, so Mammoth Biosciences was founded last year, and we are leveraging CRISPR in a new way. So typically people think about this protein called CRISPR as a gene editing tool. And it's a very powerful gene editing tool, but at Mammoth we're actually excited about using it for diagnostics as well. So instead of using something like PCR or ELISA or many other techniques like sequencing, we can actually use these CRISPR proteins to create very powerful and very accessible diagnostic tests. Yeah, so the CRISPR protein itself, there's many different flavors. So the one most people know about is called Cas9, and that's the one that people are typically using for gene editing. So at Mammoth we have two proteins in particular that we're very excited about, Cas12 and Cas13. So these are other CRISPR proteins. And Cas12 is similar to Cas9 in that it can find and bind DNA, and it then cuts that DNA just like Cas9 does. But then the trick there is that when the Cas12 protein has found whatever sequence that you've told it to find, and I'll say how you do that in a second, and only if it finds it, then it actually activates this secondary property that actually amplifies the signal. So you can actually get a readout so that you can say, I successfully found that sequence. And the typical way you can get that readout is through some sort of like fluorescent color being created, or color, a reporter. Right. And you can just see that by eye, where fluorescence maybe needs some sort of like filter or something, but it's a very visible result. So that's a great question. So we really see it as a platform. So one of the reasons we're in Taiwan is we're really excited to work with partners across the world who have interesting use cases for the technology. And because the system's so programmable, we can very easily spin up new tests for specific applications. Right. So in some places, something like malaria is most interesting. In other places, maybe it's like some hepatitis virus. So it can be a lot of different things. And we don't want to limit ourselves to just one specific class of diseases, because really almost all disease is caused by nucleic acids, and we can target nucleic acids, so we can, similar to how PCR is a platform for many, many different diagnostic tests, that's how we're building this CRISPR system as well.